Hi everyone, I welcome you to the presentation of this lecture. I'll be discussing friction and tension. Okay, so by definition, friction or frictional force is basically defined as the force that resists an object's motion on a surface. So for example, as you can see this man pushing that object, this object being pushed, there is obviously a force which is resisting this. That force which is resisting that motion is what we are calling friction. Then we have tension. Tension is basically the state of being stretched, tight. So for example, if you have a spring like that, when you are stretching it, that's the tension of force. When you're compressing it, it's compression of force. Friction has got types. So we've got what we call static friction. This one basically arises when the object is stationary relative to the surface. And there is also kinetic friction. Kinetic friction arises when the object moves relative to the surface after the applied force overcomes the static friction. So how do you reduce friction? Ways to reduce friction. Number one, you make the surfaces little more smoother, by lubrication. You make the object more streamlined, reduce the normal force acting between the surfaces in contact, and then we can also reduce friction by reducing the contact between the surfaces so that less number of bonds will be formed. These are some of the ways in which you can reduce friction. So friction is governed by laws. So the laws of friction, basically five. So the five laws of friction enumerated below, they encompass the frictional forces general characteristics. They basically aid the understanding friction of practical applications related to the calculations. So these are the laws. You can go through them. Basically five of them. And the fifth one is that one there. Okay. I'm going to discuss force and friction in two forms. We'll discuss the horizontal motion as well as the vertical motion. So under horizontal motion, you've got an object like that. This object has got a mass, has got weight which is product of mass and gravity, mg. Then there is the force in front, which is given by the mass of the object and the acceleration involved in the x-axis. Then there is the opposing force, which is the friction like that. So with that, the governing equation for the horizontal motion is this. Weight of the object minus friction will always give you a product of the acceleration and the mass of the object. There is an example. How large a frictional force must resist a block of mass 10 kg to give it an acceleration of that towards the left. So we gather the data. Mass of the object is that. The acceleration is this one. And acceleration due to gravity is this one. When you fuse those in that formula, you make friction the subject of the formula. Factorizing m, we're having that, and then replacing or substituting, we have that. So the frictional force required would be 80.6 newtons. So that would be the frictional force which will be resisting that object to move in a given direction. So under vertical force, we got an object like that. It has a force pointing upwards. That force is called the normal force. And then it has its weight itself, which is the product of mass and gravitational pull. The governing equation for vertical motion is basically normal force minus the weight of the object is equal to the product of the mass and acceleration in the y-axis. So that said, we have that as an example. A 5 kg object is to be given an upward acceleration of 0.3 meters per second squared by a rope pulling straight on it. What must be the tension in the rope? So this is what we have. That's a mass. Of course, there is a tension pulling upwards, which is the normal force, and there is a weight of that, which is a product of mass and gravity. So in our solution, we gather the data. We've got mass, we've got the acceleration, and we also have the gravitational pull. So from there, we just pick that formula, you do your substitutions there. What we are looking for is the tension in the rope, which is basically the normal force. Make it the subject there. Substitute the given parameters, and you realize that the normal force is 50.55 newtons. So this marks the end of my presentation on friction, force and friction. Thanks for watching.